Beneath our feet an ancient force churns, molten rock, heat, and pressure, always in motion. We live on a thin crust, floating atop a restless sea of magma. Most days we forget the immense energy below, but sometimes it erupts to the surface. Our planet isn't static, it's alive, dynamic, and sometimes violent. The story of volcanoes begins deep inside the Earth, where the core's heat drives convection in the mantle. Imagine boiling water. Hot material rises, cools, and sinks, creating slow, powerful currents. These currents drag tectonic plates, building mountains, carving oceans, and fueling volcanoes. The energy within Earth dwarfs all human power, operating on a clock of millions of years. To us, the ground feels solid, but in reality, continents drift and mountains rise and fall. Volcanoes are the most dramatic sign of this restlessness, a direct link to Earth's fiery heart. That snow-capped mountain? It could be a sleeping giant, with a history of explosive power. Volcanoes are portals to the world beneath, monuments to the forces that shape our planet. They remind us we're passengers on a cosmic vessel, powered by a star-hot engine deep within. Our journey through space is accompanied by the constant rumbling heartbeat of our world. The story of volcanoes is the story of Earth itself. So, what is a volcano? Simply put, it's a rupture in Earth's crust, a vent for molten rock, gas, and ash to escape. When this mixture erupts, it creates awe-inspiring spectacles and sometimes devastation. Magma, the molten rock beneath the surface, is the star of the show. When it reaches the surface, it's called lava. The properties of magma, its temperature, chemistry, and gas content, determine how a volcano behaves. Some lavas flow gently, others are thick and explosive. Think of a volcano as Earth's safety valve, releasing internal heat and pressure. Without volcanoes, pressure could build to catastrophic levels. Eruptions happen when rising magma's pressure drops, letting trapped gases expand violently, like opening a shaken soda can. This can blast ash into the sky or send lava fountains soaring. Volcanoes are not just destructive, they're essential to Earth's renewal and change. Each eruption is a reminder of the planet's ongoing transformation. Volcanoes play 4 vital roles on Earth. First, they're geological systems, visible proof of the planet's inner workings. Each eruption adds new rock, reshaping landscapes and building the world we know. Second, they're natural hazards. Eruptions can bury towns, collapse buildings, and unleash deadly flows of ash and gas. Millions live near volcanoes, making understanding these hazards crucial. Third, volcanoes are ecosystem builders. Their ash weathers into fertile soil, supporting rich agriculture and unique life forms. Even deep-sea creatures at hydrothermal vents. Finally, volcanoes influence climate. Massive eruptions can inject gases into the stratosphere, cooling the planet for years. The 1991 Mount Pinatubo eruption, for example, lowered global temperatures. Over time, volcanic activity has helped regulate Earth's climate, sometimes triggering ice ages or warming periods. Volcanoes are not just destroyers, they're creators, shapers, and regulators of life and climate. Their power is both a threat and a gift. Understanding their many faces is key to understanding our planet. Volcanoes are Earth's ultimate agents of change. Think of a volcano as a planetary pressure cooker. Magma forms deep in the mantle, then rises because it's less dense than surrounding rock. It collects in a magma chamber, a reservoir beneath the surface. This chamber is filled with molten rock and dissolved gases, held in by the weight of the crust. As long as the crust holds, the gases stay trapped, storing immense energy. Eruptions are triggered when pressure in the chamber exceeds the strength of the rock above. This can happen if more magma enters, gas comes out of solution, or an earthquake cracks the crust. When the lid breaks, magma surges upward. As it rises, pressure drops, gases expand, and bubbles form, propelling magma through the volcano's conduit. If gas escapes easily, you get gentle lava flows. If it's trapped, pressure builds to an explosive climax, shattering magma into ash and rock. The style of eruption depends on how easily gas escapes. Every eruption is a dramatic release of Earth's internal energy. Volcanoes cluster in specific places, revealing the restless nature of Earth's crust. Most are found along tectonic plate boundaries, where plates collide, pull apart, or slide past each other. The Pacific Ring of Fire is a chain of volcanoes encircling the Pacific Ocean, marking active plate boundaries. At convergent boundaries, one plate dives beneath another, melting and forming magma that rises to create volcanoes, like the Andes. At divergent boundaries, plates pull apart, letting magma rise and form new crust. Seen at the Mid-Atlantic Ridge, on land, rifting creates valleys and volcanoes, like Africa's Great Rift Valley. Hotspots are another source. Fixed plumes of hot mantle melt the crust as plates drift overhead, forming chains, like the Hawaiian Islands. As plates move, old volcanoes go extinct and new ones form. Volcanoes are the surface expression of a planet in constant motion. Volcanoes come in many shapes and sizes, each with a unique personality. Shield volcanoes are broad and gently sloping, built by fluid lava flows, like Hawaii's Mauna Loa. Stratovolcanoes, or composite volcanoes, are steep and conical, built from layers of lava and ash. Think Mount Fuji. Their thick gas-rich magma leads to explosive eruptions and dramatic landscapes. Cinder cones are small, simple, and built from ejected lava fragments that fall as cinders around a single vent. They often form quickly and rarely last long. Sometimes, a massive eruption empties the magma chamber, causing the volcano to collapse and form a caldera, like Oregon's Crater Lake. Calderas are vast, basin-shaped scars left by cataclysmic eruptions. Lava domes form when thick lava piles up near the vent, creating steep-sided mounds. Each type of volcano tells a different story about the magma that feeds it. Their diversity shapes the landscapes and hazards of our world. Understanding their types helps us predict their behavior. We can't stop eruptions, but we can read the warning signs. Volcanologists monitor seismic activity. Small earthquakes signal magma on the move. They track volcanic gases escaping from vents. Changes in gas output can mean magma is rising. The ground itself swells as magma fills underground chambers, detectable with GPS and satellite radar. By combining data, earthquakes, gas, ground movement, and heat, scientists build a picture of a volcano's state. This allows for timely warnings and hazard maps, saving lives. Prediction isn't perfect, but it's our best defense. The science of volcanoes is a testament to human ingenuity. Understanding these signals helps us coexist with Earth's power. Volcanoes are the architects of our planet, shaping land, air, and life. Early volcanic outgassing created Earth's first atmosphere and oceans. The continents themselves were built by volcanic and tectonic processes over billions of years. Without volcanoes, Earth might have remained a water world. Volcanic activity has driven evolution. Mass extinctions cleared the way for new life. Even today, volcanoes create new land, provide geothermal energy, and concentrate valuable minerals. Their ash enriches soil, supporting agriculture and life. From continents to ecosystems, volcanoes are builders as much as destroyers. They remind us Earth is a work in progress, always being reshaped by fire from within. The story of life is inseparable from the story of volcanoes. The story of volcanoes is unfolding now. In 2024, Ethiopia's Haile Gubbi erupted after centuries, revealing the birth of a new ocean. Hawaii's Kilauea filled its caldera with lava, a gentle reminder of the hotspot beneath. Indonesia's Mount Semeru unleashed deadly pyroclastic flows, a warning of subduction's explosive power. These eruptions are the planet's pulse, messages from deep within. They show Earth is alive, not a dead rock in space. Studying volcanoes is listening to the heartbeat of our world. It's a humbling quest to understand the forces that shape us. The Earth is alive, with many more stories to tell. Volcanoes are the voice of a restless, living planet. If you found this information as fascinating and eye-opening as I do, then don't hesitate to smash that subscribe button for even more captivating science content.